This is Jacob's Algebra, Chapter 14, Lesson 5, Part 2. So we worked through the first couple of problems from Set 2. Now we're going to start the rest of the problems in Set 2. Problem number 8 says arrange each of the following sets of numbers in order from smallest to largest. So we need to make sure we have the smallest first and then we go up to the largest at the end. So let's look at Set A. Set A, we have 0.6, 0.009, 0.07, and 0.0008. Which one of these is our smallest number? That's going to be 0.0008. The next smallest one is the one that has our first non-zero digit farther out. That's going to be 0.009. Then we have 0.07, and then we have 0.6. So you should actually write these numbers in order from smallest to largest. So you should go and then write them all out in order: 0.009, 0.07, and then 0.6. It's not done until you actually write them all out in order. If you just label them, if you just write them in the scrambled order that they're originally listed in and label them 1, 2, 3, and 4, that's not good enough. You do have to actually write them out in order. Okay, set B is all 0.183. We have 0.183 that terminates, and we have 0.183 that repeats with a period of 1, 2, or 3 in the repeat. So let's look at these. These are kind of hard to sort. In order to be able to sort these, let's just do one more digit on each of these. If we have 0.183 and the 3 is repeating, then the very next digit should be a 3, right? If we have 0.183 and the 83 is repeating, then next we should have an 83. If we have 0.183 and the 183 is repeating, then next we should have another 183. That will help us figure out what goes next. Now all of these start with 0.183, but the smallest one is going to be the 0.183 with nothing after it. Now, ignoring that one, what is the one that has the next smallest number after the 3? We have 0.1833, 0.1838, well that's bigger, and then we have 0.1831, that one's smaller, so this is going to be our next bigger number. Now we have to see which is bigger, 0.1833 or 0.18383, and 0.1833 is going to be the smaller of the two, and so 0.18383 is going to be the biggest. Now we need to actually write these in order. 0.183 terminating. We have 0.183 where the entire thing repeats. Then we have 0.183 where only the 3 repeats. And then 0.183 where the 83 repeats. Okay, let's look now at part C. Part C, we have square root 10, cube root 10, and fourth root of 10. Well, I will tell you now, as long as the number that you are taking roots of is a positive number that is greater than 1, the bigger a root you're taking, the smaller your answer is going to be. Like you know that the cube root of 8 is smaller than the square root of 8. So square root 10 is going to be our biggest number. So fourth root of 10 is our smallest, and then cube root of 10 is our next smallest, and then square root of 10 is our biggest. So these are actually written in reversed order. So it's going to be fourth root of 10, cube root of 10, and then square root of 10. Okay, let's do just one more set from number 8. Let's do number 8 let's do part D. Part D, we have the cube root of 1. We have the cube root of -1. We have the cube root of 2, and then we have the cube root of -2. -2. Okay, so which of these is going to be the smallest number? Well, the smallest number is going to be our negative numbers, because remember, negative numbers are further to the left. So our smallest number is going to be our most negative number, the number that is farthest from 0 on the negative side. And that is actually going to be the cube root of -2. And then the cube root of -1 is just 1, so that's going to be our next smaller number. The cube, Sarah burned popcorn. The cube root of 1, whoa, that wasn't supposed to write. The cube root of 1 is 3, and then the cube root of 2 is 4. So to write these out in numerical order, from smallest to largest, we would write the cube root of -2, the cube root of -1, the cube root of +1, and then the cube root of +2. Okay, so that was number 8. It is very similar to number 15 that is assigned as homework, which also has you arrange sets of numbers from smallest to largest. Be careful of the negatives because remember -10 is smaller than -8 because -10 is farther away from 0 in the negative direction. Okay, so now let's jump over to number 9. Okay, for number 9, they give you a table which you're going to be using also when you do set 3. So it gives you a table that gives you the square root, the cube root, the fourth root, and the fifth root for the numbers from 1 to 10. One thing to be careful of, my book has a printing error. The first column should say x. The second column should say square root x. The third column should say cube root of x. My book is missing the 3 there. And then the fourth column should be the fourth root of x. And then the fifth column should be the fifth root of x. So in your book, the third column, it should say a cube root of x. There should be a 3 there. So if there isn't, go ahead and write it in because it's supposed to be there. Your book may have it because your book might be from a different printing. Okay, the instructions for number 9 say to use the table in the book to find the rational number to the nearest hundredth that is closest to the irrational number that's given in parts A through E. Okay, so just for example, we'll do a couple of these. Part A is the cube root of 6. If we go to our cube root column and we look up 6, it says 1.817. Now, the instructions say to round your answer to the nearest hundredth. That is this place here. If you give your answers 1.817, that is not correct because that is not to the nearest hundredth. So you're going to need to round this to 1.82. Okay, let's jump down to part C. Part C is the fifth root of 7 minus the fifth root of 8. Now, these values, you just look them up in the table. The fifth root of 7 is 1.476. And the fifth root of 8 is 1.516. And when you subtract those, you get negative 0.04. You actually don't have to round that one because it does work out to exactly into the hundredth place. Okay, part D is 1 over the square root of 10. And the square root of 10 in the table is 3.162. So when you punch that into a calculator, you need to round your answer to the nearest hundredth, and you should get 0.32. Okay, the last one we're going to look at is part E. So let's go down to part E, which is -3 minus the square root of 2 all over 2. So we have -3 minus, and then we look up the square root of 2, which is 1.414 in our chart, and divide that by 2. -3 minus 1.414 is -4.414. We're going to divide that by 2, and we will get -2.207. We need to round to the hundredth place, which is right here. So our answer is going to be -2.21. Remember to always read the instructions and see if it gives you a particular place to round to. This problem wants you to round to the nearest hundredth, and that's true for number 16, which is just like it that I assigned for homework. Okay, let's move on now to problem number 10. This is the last problem. It says, solve the following equations for x and tell what kind of numbers the solutions are. Now, many of these, if you remember from way back at the beginning of this lesson, many numbers can have more than one classification. In fact, all the numbers that we're working with could be classified as real numbers. What you need to do is find the smallest subset. So if you have a cube root of something that is not a number that is a cube, then you would say it's an irrational number. If you have a number like 7, we're going to call that a counting number rather than identifying it as an integer or as a rational number or even just as a real number. You want the smallest group that contains that number to be the one that you list. So let me go back to where we are. Okay, so for number 10, let's look at part A. We have 7x minus 22 equals 0. Okay, so we can solve this for x by adding 22 to both sides, and we end up with 7x equals 22. Divide both sides by 7, and we have x equals 22/7. Well, that's a fraction, so that's going to be a rational number. And that's all you have to identify it as. It's just rational number because it's not an integer and it's not a counting number. Okay, let's look now at part C. Part C is x plus square root 2 equals square root 8. Well, remember, we need to simplify our square root 8. That can be simplified as 2 square root 2. So what we can do now is subtract square root 2 from both sides, and we get x equals square root 2. Because if we have 2 of the square root 2's and we take away 1 square root 2, we're going to have just 1 square root 2. So that is irrational because we can't actually take the square root of 2 and get an actual decimal that ends or that has a repeating value. So x is equal to square root 2. That is irrational. Okay, let's get a new page. Let's jump down and do part E. Part E, we have x times x minus 4 equals 5. Okay, what we're going to need to do here is distribute this x across the parentheses. We'll get x squared minus 4x equals 5. Now I'm going to subtract 5 from both sides to get x squared minus 4x minus 5 equals 0. And now I can factor this equation. So I'm going to factor it as x minus 5, x plus 1. So x can be equal to, and all of that equals 0. So x is either going to equal 5 or negative 1. So if x equals 5 or if x equals negative 1, this equation will multiply to 0. Okay, 5 we could identify as a counting number, but negative 1 is not a counting number, it's an integer. So our entire solution set we're going to say is integers because 5 is a counting number, negative 1 is not. Okay, we'll do just one more part from number 10. Let's do part F. Part F is square root of x plus 9 equals 16. So the first thing I'm going to do is subtract 9 from both sides to get square root of x equals 7. And now I need to square both sides to get rid of my square root. So I will end up with x equals 49. That is a counting number. And that is how number 10 works. It is just like number 17. You're going to solve the equation for x and then tell what kind of number x is. All of these can be identified as real numbers, so don't give real number as an answer. If it is a counting number, then counting number is what you need to say. If it is an integer and not a counting number, then say integer. If it is a rational number that is not an integer and is not a counting number, then say rational number. If it is an irrational number, then you're going to say irrational number. All of the numbers we've been dealing with are real, so don't say real because we know all of them are real. You won't do anything with imaginary numbers until Algebra 2.